Okay, so for the next talk, my name is Yves Goeleven, for those that don't know me. And yes, I'm narcissistic enough to call my service to my own name. So I'm talking about Goeleven.com. Goeleven.com is a project I started almost 1.5 years ago, in January last year. And the reason for this is because I've been talking to many consultants and colleagues at companies. And every time I talk to these guys, the topic was always the same. Either it was shitty traffic. I spent like 4 hours a day in traffic during the winter season. It's not that pleasant, and a lot of people have the same problem. And another one is what I call the enter prison. You know, that feeling when you come in at a certain customer in the morning, you first have to go through the security gates. I got locked out this morning, so been there again. And then they present you with this computer, this all Windows XP Service Pack 2 at some customers with 1 GB of RAM, a small disk, 5,400 RPM, with a big virus scanner on top that will absolutely make sure you cannot work. When you try to go out, for example, to a blog or something to get information, they will block you. So, well, that's why I call those damn things enter prisons. Right? And we all know that thanks to cloud computing and the advances in mobile solutions, we could actually be doing this. We could be sitting anywhere on the planet, coding, having fun, not being sitting in the traffic jam. But there is one slight problem, and that's our working culture. No matter how hard we try, especially as a consultant, you will not be allowed to work from anywhere in the world. Maybe it will work if you work internally, right? Especially at my employer, we can work at home, it's no problem. But I cannot do it for my customers because they do not trust the consultant. Right? So it was the same story over and over and over and over again. And that's why I decided to turn my name into a solution, hopefully one day, and fix this problem. Right? Now, in my opinion, if we want to fix this problem as people, then I think we need to team up. And we need to try to collaboratively figure out how we can actually create passive sources of incomes. And as developers, I think we're absolutely suited for that, because we now have in the cloud or in mobile solutions, we can build these apps, these SaaS services, these PaaS services, or even write books and things that we can create and then try to figure out how we can market it so that we can turn it into a passive income. A passive income does not mean that you do not have to work, right? Some people think that. But it means that the investment of your time is not directly related to the money that you make. So apps, services, online cloud apps like Foxboy, like MyGet, like maybe one day Goeleven.com, are things that could fit into the schedule. Now, what I envisioned as the solution, and as Panos said, this is all based on assumptions, so I had to test them one by one, is actually that I want to group some people online in a community or a social app. Right? So Goeleven.com is actually a social platform where the intention is for people to meet, to talk, to collaborate. And then we use the cloud, in this case especially Windows Azure and its ecosystem, to actually go and try out ideas. Panos had an idea on the beach. He wanted to create an online call center. He has to try it out as fast as possible. Same for MyGet. Same for a few other startups that I know in our community. They all do the same thing. They have this idea. They try it out and they try to get feedback. Do this as fast as possible. Because, as I said, everything you do or everything you invent on the beach or wherever you are, it's an assumption and it's probably false. Test it. Build a small mock-up, throw it online, go for it, capture feedback. You will see that it doesn't work, probably. If it works, you're very lucky, but probably it won't. And then try to get the data from it, try to get the feedback from it, and reiterate. Change a small thing, try it. And that's what I want to do with this community. It's like bring a bunch of people together that work on certain apps or certain services or certain ideas, and then iterate through it using cloud, using feedback from the tests, and go forward. I want to support this by two things. One is the boring part, which most people is the only thing that they actually use from it. Those are collaboration tools. So these are inside to-do lists, project lists, small Scrum board-like features that you can actually use to manage your tasks, your projects, your IDs, give each other feedback, etc. That's based on the getting things done methodology. Most people are familiar with that, I guess. Who is not? Who's never heard of this? Yeah, okay, that's fine. So you can use it. And besides the tools, I also think that the people that are flocking together there, they're almost all devs. But to get the product out, we learned that we do not have the necessary skill sets. We are good at developing stuff, but we are absolutely not good at marketing stuff. We're also not good at legal questions or accounting-related, billing-related questions. It's hell, right? So we need additional people. We need more people. And that's why I envision this marketplace, where actually professionals can offer their services to the groups to actually realize that. Now, I validated a few assumptions already. So I validated the assumption that people will use the tools. They do. They use it every day for managing their personal stuff. Also validated the ID tryout on Azure. You know this from Voxboy as well as MyGet and many others, that people are continuously trying out new IDs online. I also validated the marketplace from the provider side. I actually went out to small companies during end of last year and actually asked them to join and come online, etc. That worked until they noticed that there was not a huge community a la Facebook on there, and that's when they backed off. So they are prepared to actually pay for offering services to people, but they need a critical amount of people. So now my next challenge is, how do I get this huge amount of people? And that turns out to be pretty much impossible, because if you want to reach a huge amount of people, you actually also need a lot of money to reach them. You need to have advertisement, you need to have television, yeah, what's it called, shows, but the advertising parts. You need to be in Google AdWords, but not just for $50, right? A lot more. If you want to attract a lot of people, then you actually need to invest a lot of money, and I do not have a lot of money. It's very simple. So that's why in the beginning of the year, I actually decided to go niche and just started a very small group of people, right? So all developers that have interest in cloud computing, mobile, and things like that, and that have ideas and want to realize them. Right? So I'm now switching a little bit, and I'm now trying to figure out how I can activate you guys. I already tried one test, is putting a part online where you can actually submit IDs and then give feedback on the IDs. It doesn't work. And the feedback that I always get is, well, I don't want to tell my ID. I don't want my boss to know that I'm working on a startup. I don't want my colleague to know that I'm working on that because he's going to steal my ID. So I'm a bit stuck there at that part, but we will get there. But it's a basic story that also Panos mentioned. Everything you do if you build something online on your own or with a small group of people is all based on assumptions. And you have to validate them one by one and try to figure out the solution to the problem at hand. Right? But one by one, test it, get feedback, and start as soon as possible. The first version of Goeleven was just, I think it was online 2 weeks after I got the incentive to actually start. The idea was there already a long time because people have been nagging to me about that for, I think, like 7 years now. But I only decided end of 2011 to actually start. Okay, now the important part, the architecture. If we look at it from a functional point of view, it's actually a pretty simple application. One is, there is task management part, where you can do, where you have to-do list, you have an inbox. Your inbox is actually a place where you can dump your mind and organize it. You have these project lists, where you can actually select things that you want to do in the near future. You have something called context. Context is a place, location, and a time, so that you can group tasks. And the system will only give them to you if the context applies. For example, you can create a context at work, you can give it a location, and then the system will look at your current location where you actually are, And it can decide that you're now at work, so I will give you this to-do list, basically. If you're at home, you will get another to-do list. If it does not fit the time constraints, it will not give you the tasks. If you only have to do some certain tasks in, let's say, a month, it will actually postpone it for you so that you do not have to think about it for a month. That's the kind of task management that you can accept. It's also very personal task management, so we do not work as big groups of people. These are startup ideas of people that want to turn something into a passive income source, right? This is something that has kind of a trust boundary. So for every idea, you can select the people that you want to work with. Not nobody, just you, or just a few of your friends, or just a few professionals that you trust. So it's not like Facebook, everything is private, it's very small groups working on a central level. Now we have also all kinds of social features. This is all based on Signal that you can talk to each other in real time. A little bit Facebook wall style that you can do. And I also have a marketplace, which most of the part the code was in billing, figuring out how to do the subscriptions and stuff. It's pretty difficult to get it, mostly from a legal point of view, and knowing what you have to charge and when and who and where they come from. But besides that, technically it's not that difficult. And then also important is the backend. The backend is actually a very scalable event-driven architecture that I had designed for the masses of people that would be coming to me. You notice they don't, right? What does an event-driven architecture look like? Well, this is 50% of the solution. And the other 50% is like a small block here. Right? The other 50% is just an ASP.NET MVC app that reads from a storage account and renders HTML. Okay? You can think of that very simple. Just reads, doesn't do anything else. On the processing side, whenever you do something in this site, in the website, it's all actually a lot of client-side JavaScript code. So if you drag and drop items from your task list or project stuff, you get immediate feedback. It just does whatever you tell it to do. And it does not go to the backend to process. It doesn't make you wait. It doesn't do that. What it does is just captures the fact that you did something and sends that to the backend. And the backend has to deal with it, no matter what. That's what an event is. Right? Something happens. You capture the fact that happens in a message, and you send it to everybody that cares. In this case, my backend. You do not go like in a request reply mode where you wait until everything is processed before you give the user a big middle finger that he entered something wrong. We don't do that. Okay? So we just capture what the user does, we send that to the backend, and the backend has to figure out what to do with it. The pushback that I typically get on this architecture is, and what about errors? Well, they don't matter. Right? In this architecture, you have sent the entire context of the user. You know what he did, why he did it, when he did it, where he did it. You know everything. And if you have an error, you just put the message aside, you fix the bug, you deploy again, and you put the message back, and it happens. Right? The UI has been designed for this. I mean, if you have ever used it, you have ever been there when we had an issue or something, you might have noticed that some actions disappear. You have the same on Facebook. You have noticed when you're typing or chatting a lot on your wall, and then you press F5 very fast, you will notice that your messages are gone for a while. It's the same architecture, please. Just try it out. But so I tell you that everything has happened, but in reality, I just sent to the backend, well, this is what happened, and now you fix it. Now, how does it look like from a technical point of view? We have a bunch of event sources. These event sources can be anything. Right? It could be a website, or it could be a mobile app. Because in the end, it's just a standalone client where stuff happens. Whenever anything interesting happens, it's packaged into a message. And this message is sent to a gateway. I have a few protocols supported because I needed them all. We use WebSockets. This is Signal. Right? We use the REST API, which is MVC Web API. We also have an AMQP endpoint. This is the Azure Service Bus right now. The preview one does support AMQP. And I can also, but this is just for myself, upload a big bunch of events and have them reprocessed again. This is especially important when somebody asked the question earlier, what if you have data structural changes? Right? If I have data structural changes and I want to reinitialize everything based on how it would have been if the changes had been in place, then I can just simply pick my list of events that I stored, push them through the system again, and restore the state as if it has ever, or it had been like that all the time. That's another nice side effect of this architecture, is that you can actually do that, because every message or every event will be handled by the system with a certain type of delay. This delay might be 1 millisecond, but this delay might also be 3 weeks or 5 months, doesn't matter. Okay. Now, once the gateway has accepted the message, it will enrich it a little bit with the context information that I do not trust the client from. For example, security information, time information, stuff like that. And then I put it on a transport channel. Here I also have choices in Azure. I can choose between storage queues, or I can choose between Azure Service Bus. I actually use both today, but I'm going towards everything on Azure Service Bus storage. But I have a hybrid situation today. I have multiple channels, the messages go either way. For fallback reasons, I might even keep that in the future, both. But topics are definitely going to be my main transport.
Why are we moving from queues to subnets?
Well, very simple. It's the latency. So Service Bus has TCP connections. Those are always open. You do not have to do a HTTP request to send a message. It just goes. Right? The connections are open. So the latency that you have is a lot better. Besides that, from throughput perspective, it depends. Right? Azure Storage Queues has a guaranteed space, very guaranteed throttle, I should say. I think you can never have more than 2,000 requests or operations a second. While Azure Service Bus does not have this throttle, so either you get a lot or a little bit. Depends, right, on what your neighbors are doing. So you have to make a decision, either latency is important or throughput is important. That's up to you. But I favor the latency, because that way I have your events a lot faster. It feels more real time if you use the application. Then I also have a bunch of, just for your information, these are lab roles. Right? I have a backend of worker roles where everything actually happens. And these worker roles, they have a concept called handlers internal. And the handler is a small piece of code that executes whenever a certain event type arrives. This is handled by a framework that I also work on called Service Bus. So if I send a user logged in event, for example, here, there is some kind of code that says, well, I want to run when I get a user logged in event. And then the system will invoke that piece of code. I have many of those handlers, a few hundred, and they are all sitting on these worker roles happily next to each other, and they will be invoked whenever it happens. Then downstream, I'm using a bunch of other services. The majority, of course, Windows Azure Storage. I'm not using SQL at all. There's no SQL in my system, just because I'm not really SQL fan. But that's just personal. If you want to use SQL, go ahead. But I'm also using a couple of other services, especially, for example, like PayPal, like MailChimp, like SendGrid, like those things. And we also have, this is also important, we also have callbacks to Signal hubs. So whenever a certain event happens in the backend, I can actually send it back to the web browser and notify users. In a few cases, you will see that if you use the system, I actually decide to wait there. For example, the first time you log in, you have to create your profile. So the entire system doesn't make sense if you don't have a profile, because I cannot attach the data to anything. So that's why I make you wait there. So if you log in first time, you'll see that it creates a profile. A few other places, I think when you register your company for the marketplace, same thing. I'll just make you wait. Only 1 or 2 places. All other stuff is just, it happens, I noticed it, I send it to the backend, and you just happily follow. Okay. So that's basically the architecture. And this is also one. Everything that happens will also be captured. Captured means I just get the message, I put it into blob storage as long files. I can then use these files later through the file to reinitialize everything if I like. So I have a backup, but not in the sense that I have a duplicate of my data, but I have a duplicate of everything that originally happened. So I can restore the state of my data. For two reasons. One is if everything crashes, I can recreate stuff like that. And the second one is if I have structural schema changes, I can just drop my tables and reinitialize everything into the schema structure. It's a very easy architecture, and it has quite a few benefits from a management point of view. First, a little bit of extra advertisement in between. Right? I want to take this infrastructure that I actually built to scale. I tested it, but never had to use it. But now I want to offer this to other parties as well. And that's my project that I call Message Handler. For those of you that follow me on Twitter might have noticed that I started working on something else. Well, technically it's not something else. It's the same backend that sits underneath Goeleven.com, but it will be exposed in a multi-tenant way so that you can reuse those same handlers. So if you just want to capture your data stream of events into tables or blob storage, you can just simply select the handler for you and it will collect your data. In your account, not in my account. Okay? Important. Other things, if you want to, for example, count certain number of message types that come in, you can just simply select the handler and get it. So in essence, it's the same thing, but it will be surfaced on the internet in two different ways. You will notice in the future that I will do the same for the other three parts of Goeleven.com. I got a lot of feedback from people that were confused, like, is this a social site? Is this a task management tool? What is this? Right? So I decided to, in the future, go and split things up. Probably the task management will be its own app. Goeleven.com will always be the community part. It will probably be free just for people to get it. Okay, so why did I choose for this architecture? Well, there's 5 key benefits. One is it's loosely coupled from an implementation point of view. So every event generator, whether it's a website or a mobile client or some device in the field, doesn't matter, it's decoupled from the handling of the messages. So I can reuse the same logic for different type of applications. Also, from an update point of view, I can actually easily take one of those handlers down and deploy a new version. No problem, because everything is separated from each other. And because the context is in all of the event messages, I can just simply continue half an hour later if I have a new version, or 5 minutes if my deploy went correct. So also from a distribution point of view, the event generator and the consumer, because there is this gateway and this channel in between, they can be anywhere in the planet. So having multiple data centers, just very easy to handle. You just deploy one part of the handler in the US and another one in Europe, and you're done. That's it. Okay. Same for the clients, they can be anywhere. As long as they have an internet connection, they can hit the system, and the topics will distribute everything across the different parts. The only thing that you have to keep into account is, of course, the bandwidth costs if you cross networks. And secondly, there is, of course, latency. If you start duplicating events from Europe to the US, it will take a little bit longer than local. But it doesn't really matter because the system has been designed with this fact in mind anyway. In your browser, you just see as if everything happened correctly, or already, I should say like that. And then the message will be, instead of being handled 10 milliseconds later, it will be handled 1 second later. But you don't care because you still see the end result. Okay. So also, yeah, processing time. So because all of this information is encapsulated in this event, I can take parts down without issues and then bring it up later again. So your browser doesn't notice. It already happened from that perspective. So it's just the persistence in the store that happens a little bit later. Also from a big data Point of view, it's very interesting because we can capture all of the contextual information and process it. So we can look at what are users doing, why, when, for what reason. We can analyze it later. And also for evolution, every part of the system is actually standalone and can evolve separately. And if you have a new feature, it typically does not mean that you have to update anything. You just add another handler. That's it. And usually another JavaScript file. And then you're done. So you just add if you have new features. If you have features that nobody uses, you just delete those things and you're done. Okay. So those are the four main characteristics. And then for Azure specifically, this is also, in my opinion, one of the only architectures that actually allows you to get the most out of table storage. How many of you are familiar with table storage? Who likes it? Except for, no? Okay. Why do you not like it?
You can't query it.
You can't query it, yes, you cannot query it. That's correct. Well, you can query it, but it's a very big pain in the ass to query.
Yeah.
Especially if you have a lot of data. I have a talk on this. Explaining why this is takes me more than an hour, and it's a level 666 talk, so look at it at your own risk. But the reason for this is because it's a very, very big system. And the way that you go through it or fix it is to actually not query it, but instead store the data upfront in the structure that you later want to query. It's a very different mindset. I will come back to my approach to this later.
It's denormalization.
Denormalization. Well, I'll come back.
That's the idea.
All right, let's look at some technology. I already said a few things. Currently, the front end is a JavaScript-based, almost a single-page application, but there are many pages. But the concept is the same thing. The MVC is basically just rendering pages and rendering JavaScript, or giving you JavaScript. And then all other stuff happens in the client side. The data sits already prepared in table storage. So if you go to your inbox page and you see your tasks over there sorted in a certain way, that is because I pre-ordered them like that in table storage. I'm not bothering with querying or whatever, it's just, that's how I give you the data, straight to. If you go to another page, you'll see the content of another table. For you, it will look like the same content. It's conceptually it's the same task with the same to-do item. But in table storage, it's all duplicated. So I have your data many times. So lots of JavaScript, and then whenever anything interesting happens in the UI, I will just package it up and send it to the backend. You will not notice. It's just SignalR that actually sends a JSON message back to the gateway, and then it will be processed in one or many ways. I also have plans to go mobile. I'm not there yet, especially for the task, the task tools. It's very annoying to open a website. If you want just to look at your to-do list, what the hell do I need to do now? And then you need to open your laptop and go to your browser. Or worse, go to your phone and go to Zoom. It's not a responsive UI, so it doesn't really work at all. But I want to go for native mobile clients, for probably starting with Windows 4 and Windows 8, and then if it's a success, I will go to the rest. In this case, it will be Web API for reading. Authentication is, in this case, used also by the ACS. Right? Just stole Mark's code and implemented it. I also have SignalR as an option for apps. And I also want to go for the MQP support now that the client-side libraries for that thing are getting more mature for mobile services. I think we have one for every platform right now, so we can use it. If you look at the backend, it's a little bit more interesting. The gateway itself is currently looking like this. It's a web role, 2 instances, just for those that ask the question. Too small, and some days extra small. If I just, it's enough. I do not get millions of users. I can handle a few hundred at the same time, so that's okay. SignalR is hosted in there, Web API is hosted in there, as well as the client side of InService Bus. So the people that are familiar with InService Bus, I'm actually running a unicast bus instance in here. Everything that comes in from SignalR is automatically pushed to an service bus and then replicated to the rest. Web API, same story. Any request that comes in for state changes will be packaged in a message, put into a service bus and sent to the backend. So it doesn't really do anything besides serving content and handling connections. But that's why I also have enough for just a very small machine. In the backend, it's mostly Windows Azure Service Bus and also some storage. And this is the ideal situation where I only use Windows Azure Service Bus for the small messages and Blob Study for the big stuff. So if you want me to, if you upload, for example, your profile picture, I will resize it in different thumbnails. That's too big to fit through Service Bus, so I will sidetrack it using Blob Study. There is still a little bit of storage queues as well, but they will disappear. In the backend again, then I have worker roles. Actually, every handler has been designed to be a worker role on its own. So if I would deploy that straight to Azure, it would be 100 and something worker role instances times 2. Okay, I can't afford it. But I'll come back to that later. Right now, these handlers are grouped in worker role instances. I can group them in many different ways. But right now, what I actually do to save money is I will put them here. They can do that. So I will explain it later now. So the handlers, they have a specific part of business logic. They are standalone. I can put them anywhere and they do not need each other. Important. And this is also orchestrated by NServer. So this framework allows me to just write small pieces of code. I'll show you some code later on how to do that. So these are workloads. I can put them anywhere. It doesn't matter where I deploy them. I can put one instance in the US, the other one in Europe. It still work. Okay, so what does it look like in code? So this is the MVC part. MVC part is typically just a controller with some authentication and profile requests, so that if you're not logged in, I will ask you for the login. I will always figure out who you are, your profile. That's why I said I cannot allow you to continue without actually having stored your profile. And then in this case, for example, this is your to-do list. I will find your active context. So where are you working today? And then, unless it has been chosen, I will find the one nearest to you. So this is based on proximity, based on your location. If you share it with me, most people actually don't. If you do not share it with me, I'll try to figure it out anyway. I'll do it a little bit less accurate. And then I just return a view. And typically I will also have a child view. In this case, the action list for the specific content. Again, this is cached. I will find the actions that belong to the context. I will query them. So typically all queries are done in memory. So if I want to split them into 3 columns, I will go to the database once, to the table storage account. So one call, I will pull them all out. And then I will process that in memory. At any point in time, I try to keep your data under 1,000 records and everything in the same partition, so that I do not have to go multiple times. Now that's returned to the client, and then on the client, you clear JavaScript, huge files of JavaScript that work on your data. And for example, this is your drag and drop part in the to-do list, where you can go from to-do to in progress and done. So when you drop, what I actually do is figure out where you dropped it, and then I send a message with all of the data in. And then I use the action hub. This is a SignalR construct, and I just call my event and I send a message. And then I continue. I just simply accept that it has been dropped, the UI has been updated, it's all okay. I just send it to the backend, and you just continue to work. This is very easy from also from a scalability point of view. I never have to reload the page or whatever. It's very easy. You just do all the processing for it. Okay. So when it then arrives in the gateway, there I have a class called Action Hub. This one is integrated with NService Bus, so the people that know NService Bus will see the iBus implementation. I will add the event information for the parts that I do not trust the client, especially the security information. I will parse the claims that came in from ACS that have been encrypted and not I only can read. So I will use that and override whatever you gave me in the event. You can actually supply a username in the event if you want to, but I'll override it anyway. I know who you are, so I'll override it. And then I send it to the bus. This is actually an abstraction layer on top of the entire communication infrastructure. And this will make sure it arrives at one of the worker roles. Depends on the routing rules where it actually ends up. On those worker roles, I have classes like this. These are automatically brought into memory whenever the worker role boots. And you can see that it implements an interface with an event type. And whenever such an event arrives at that node that hosts this handler, it will invoke this method, and the code will actually start. So in this case, it's basically get the data, check the data if it exists or not, if it's in the correct state or not, whatever, and then persist it again. Typically, this is one I tried as much as possible to have per handler only one call to storage. Because if you have multiples and you get an exception in, for example, the third call to storage, the system will do a retry, but then you have to check if the first and second step, for example, have already been executed. So you know that you do not have any kind of transactions, and definitely not distributed transactions when working with storage. So this is the way to fix it. Have handlers that work when a message is read from a queue or a subscription, and do exactly one thing in that handler. If it fails, then you get an exception. The message will be popped up back on the subscription or the queue, and it will simply retry again. If it succeeded, then that's your only call, and you're done. Okay? If you have multiple things to do, then it's always wise to, at the end, publish or send another message or event, and just trigger another handler somewhere. Okay? So that way you can actually separate all your steps apart.
Question.
Yes?
Getting the item from the repository,
yes.
Imagine that's some kind of a rebuilding of events, or?
No. Yeah, it exists, I know. So there are two ways to actually store your aggregates. One is storing it, like in a database or a table or table storage. And the other one is actually persist the events that have been emitted by this aggregate events, and then replay that to recreate the state. I know it can be done, and I actually planned to do it when I started the project, but I just haven't come around yet. In the end, I do not really see a lot of benefits because I still have your events. I can push them in again, and I will recreate the table structure. So
you basically have two storages. So you
yes.
have like your domain, like in snapshot mode.
Yes.
And one would be the entire audit log.
Yes.
Log.
The downside is that if I need to recreate everything, I need to process the entire audit log again. But I could indeed have a third one, where I only have the views of the pages in table storage, and then have the aggregate state as a small event log itself. And I could recreate the aggregate from the event log. But then I had three storages, because then I had one for all the entire audit, one storage per aggregate, and then again one table per view.
So you're using ORM to persist the aggregate, or?
I'm using simple data. So simple data, I'm probably one of the only people in the world that uses it. Simple data is a very magnificent, it's not an ORM, right? It's something to read simple data, but it has an Azure adapter. It's not, it doesn't really have a lot of love from the person maintaining it, but it works. Right? So it does whatever I need to have, and I really like it, so I use it. If I find a bug, I will submit a pull request.
Like, when is your transaction finished? Is when you write to your repository and publish the message?
I have no transaction. Okay.
Well,
no, I do not have a transaction.
Okay.
If I do this, save all changes and there are multiple elements of the same partition, then I do have something that looks like a transaction because it's just one call. right? So I have one call going with all the data, and it fails entirely or it succeeds entirely. So it looks like a transaction, but it isn't a transaction. It's just one call. If I have another call here that publishes an event, then that one might actually fail, while this one actually succeeded. It's not the same. There is no transaction.
And what do you do then?
It retries.
So you retry, you skip the last part, and you try.
That's why all these weird if checks are true.
Yeah.
Yeah.
Okay.
So it retries. It will get the data again. The data is there. The data is not in the state that I expected it to be. So it will do nothing, basically. Okay.
I'm wondering how that would work with a third-party system that does, I don't know, payment or something.
But it's the same thing. Right? Actually, it is the same thing. If you have a failure but later, you need compensation logic. You need to know how to make things right again on the other side. Typically, it depends on what it is. Typically, it fits in here. So you just simply treat the remote service the same way as this. First, you go check for the current state. Is this the state I expected to be in? If so, execute the question or the command, and then send the publication that is succeeded. In some cases, it's more complex when you have multiple parties to synchronize. And then we have in Service Bus a concept called Saga. Saga is actually a set of handlers that have some shared state. And regarding that state, you can look at where did I get. But again, saving the state of the Saga is not in the same transaction as doing things. So it could be even that your Saga is out of sync with the reality. So you still have to go and check, did I already do this or not, for every step in the process. That's why it's very good to split it up into very small parts and make sure that every part is only exactly one thing. Then it's easy to handle.
But if you're referring to billing systems, then there is a compensation logic is very simple.
Yeah.
And in Volkswagen, that's what we do. So forecasting is not correct. None of the time is actually correct. This does a prediction. And then when the real price comes, we just add the real price there and we take the difference. So the compensation comes from the payment gateway itself. So if you charge somebody more, then you get the IPN back, the notification from the charging service that this is how much I charge. This is actually your compensation logic. And we just do that.
The idea is basically that one handler is never, let's say, always consistent, and potentially you need some compensation.
Correct. But if you work with payment gateways, I know I work with PayPal, they have this concept of payment key. And if they have seen this payment key before, they will not accept it a second time. So you will know that this payment had already been completed, even though your local state thought it was not. Okay. But you need to go to it. You need to catch that exception then and update your local state like this happened before, and things like that. So you need to actually change the way you think and the way you code to actually be able to support it. The same goes for SQL. You know, SQL does run in a transaction, but only this part. If you do something else outside of the transaction, it's not in a magic distributed transaction like you're used to on premises. It's not. So even if you use SQL, and even if you're in a transaction scope, please still include all of this logic, because it will happen. Okay. I can have multiple of these in parallel. So this is another, I handle messages for the same action in progress. In this case, it's a completely other aggregate that needs to be updated in response to the same event. This happens next to each other, so it's completely independent. That's also why I want them to be in separate processes, because if they're not in separate processes, they will not be independent, because they will be called all together. Okay, now if I want to go back to the user, in case of the action in progress scenario, I did not go back to the user because he knew, right? But in some cases, I need to get back to him. Like for example, when you vote on an idea, if you like it or not, I can only allow you to vote once, otherwise you will go vote. So in that case, I get this voted on ID event from the UI through the gateway, through service bus to the backend. I will do my logic, whatever that is, and then if your vote gets accepted, I will publish a new vote accepted event. This logic is important. I need to make sure that you have already voted before. but I need to check if you have not. And then on the client, so in the web role, there is another handler which catches the vote accepted one. And this one then pushes the vote accepted message using SignalR's infrastructure to actually push it back to the user. I'm using a group here for the user because a user can have many windows open. I want to send the message to all of his open windows, no matter what machine, whatever it is. So I actually create, in this case it's a project, but in other cases the user. So actually I create a group for every user with all of his connections in there, and in this case for the project, everybody that's looking at the project right now is also. And then I will trigger the vote accepted method on the client side, and that will make the +1 or -1 work. This is then the handler on the client side, very simple. I just simply pass the text that I get back, and I do a +1. Okay, lessons learned from building this thing. Besides functional, that you need to check everything and try and test, and if you run into something, try something else. These are purely technical things. One thing is, my way of thinking is very expensive. Making every handler worker role is very, very expensive. I figured that out after 2 worker roles. So I didn't want to do that. And then I figured out a way to actually save myself a lot of money, but still be able to scale later if I ever be successful. If it may one day happen that I have the size of Facebook, I don't know. But whatever happens is, I have these worker role code, right? So the same code as a regular worker role, but what I do is I remove it from the cloud deployment package. So I remove the link to the worker role, and what I actually do is I compile it and I zip it together with an exe file. And this exe file has been created so that it can parse the worker role, the role entry point that's typically present for doing Azure. And then it actually instantiates everything that needs to happen. Right? I do not have to do a lot of things actually, because if I deploy these things, they are already in another web role instance. So all of the other infrastructure, it's magically inherited. So if you need to do diagnostics, it just gets the diagnostics agent from the parent. It's actually another service on the system. So almost everything that's on there is just simply available if you run any kind of exe in the backend. So
why didn't you use meth to find the interfaces and then just bring them?
Because I want them to be in separate exe files. I want to be in separate processes.
It could be that you just spawn different application domains and then different processes.
Well, the service bus is not designed to allow you to do that easily. You want an additional exe file. Okay. So I have these additional workers. So what actually happens is, in a web role instance, you actually have 2 processes running by default. One is IIS, and another one is a very small web role. I cannot exactly remember the name of the process. But there is a small process that actually executes the code that you can find in webrole.cs. And in there, I actually download all of the workers from blob storage as a zip file. I unzip it to local storage, and then execute the exits. But not just execute, also start monitoring them if they die. I want to start them again if they get updates in blob storage. I shut the process down. I just kill it. Right? It doesn't matter. Everything is in the message, so I just killed it. Then I install a new one, start it again, and I'm running. Right? But this is also core infrastructure that I'm using for the message runner stuff. I can host everything on one machine basically if I do not have a lot of load. But typically I run in this configuration 2 web role instances with exactly the same worker role configurations. I can vary this. It's really possible to have, let's say, if I have 4 web role instances, to just deploy worker 1 on 2 of them and not on the other 2. I can just simply balance my load with that if I want. Okay, and then the biggest learning for me is the way to work with table storage. This is really not that easy. We are all, I typically call it abused by the third normal form people. Yeah? Since you have been in school, you have been learning that you should never duplicate data, you should never denormalize, you should have these nice tables with relationships and primary keys and foreign keys and unique constraints and blah blah blah. You don't have that kind of stuff in tables.
You don't need that.
You don't need it but there's one thing that you need to do is to change the way that you think. That's important. What you need to do to use table storage the way it's supposed to be used. What I do is I take an aggregate entirely and I store it in one table. So imagine I have this order and this order line concept. I will put both the order and the order line in the same table. With every object the same partition key, and the only thing that I vary is the row key. Row key is used for ordering typically, or for, in a lot of cases as well, to include metadata where in the parent actually the object fits. So if this is a very complex tree, like for example a parent object, a child object, and another child object, I need to know where does this one belong to be able to recompose it again. Right? So that's something I also might put into the row key. Because the row key is actually not used for a lot of things really, it's just for sorting. It's not a unique identifier. The only thing that you need to keep in mind is that these two in combination need to be unique. You cannot have same partition key, same row key. So I have dedicated partition for every aggregate. I vary the partitions depending on the business need. So in every table you actually have a number of parameters to play with as an index. One is the account itself. You can definitely use many storage accounts. For example, you can put all European data in one storage account and US data in another one. Right? Then you can again play with tables. You can create as many tables as you like, I think, or at least a lot. You can, for example, create a table per user. It's no problem. Or I think in my get to do it a table per feed. Perfectly possible. And then within that you have the primary, the partition key that you can play with again. So actually you already have 3 indexes. If you need more indexes, then you need to maintain them yourself in an order. But you can play with that already. I typically use entity group transactions, which basically means that everything I do is scoped to one partition, and then it will be inserted, updated, or deleted as one call. So one REST API call, which looks like a transaction. Okay. It's not a real transaction, but it looks like one, at least. And yes, you know, row key is actually only used for ordering. Important is you can leave it blank. I struggled with this for quite a while. Sometimes I did not really have a good row key to choose until I figured out I can leave it blank. So I will just use this as my primary ID, and I will leave that blank, and I can always get the object.
The only thing to be concerned here is that if you're using only, if you're only using the row key in your query, so the best performance is between using the primary key and the row key. That's the top performance.
If you want to have exactly one vector.
That's generally you get the best performance from that. Then it's only that one, and then you end up into table scanning if you don't have any of those. So if you do like or whatever, but if you use the equal sign on both of them, PK and row key, you get the best performance.
You get the best performance for one single record.
For the partition itself.
No, for one single record.
Yes.
You will only receive this one if you get put both in there. But typically, if I want to work with these objects, I pull them out as a block in total.
Yeah.
Okay. So I just select on partition key only, and the partition key will make sure that the data sits on the same partition server in table storage. So for a bunch of records, it gives you the best performance to always specify the partition key.
Yes.
Because then you end up on one server. If you do not specify the partition key or only part of the partition key, it might be that you end up with many services. But I explained this in my talk on channel 9.
The worst part is that you might end up doing table scanning. It takes like forever.
Yes, and the worst part, you have a billion records sitting on a few thousands of machines, and you will be querying a few thousand times to get them out.
Did you consider like other storage engines, like I don't know, document storage or something?
At the time, no.
But now in hindsight?
In hindsight, well, still no.
Okay.
Now I got used to this. No, at that time, yeah, I think at that time it was the only viable solution out there, unless you started installing stuff yourself on the cloud services. There were no VMs at that time. SQL was still very, very early. You couldn't hammer it like you can do it today. So at that point in time, I felt table storage was basically my only option. Or I would have to go through a lot of install scripts in my startup task and install something like RavenDB, etc. But those have issues themselves as well, because typically they write to disk, so you need to mount disks. It's always a lot of issues. So at that time, no, it wasn't really a choice. I just went for that. Now that I know how to use it, I wish there was more query capabilities, that I did not have to maintain all the indexes myself, because that's the rest of the slides. But in hindsight, it's very good service once you get used to using it. I'm using simple data, and also for one reason, this makes it very, very simple to do this. If you had previous, so the old storage client, it's nearly impossible to actually query one table for multiple types of objects. The new one is better, but still not as easy as with simple data. Because with simple data, you can simply use, refer to every record, basically as an object of the dynamic type. And you just check if the property is there and you use it. That's it. It's very, very simple.
Yeah, but the new library returns the same concept now, so you can do that.
Yes, but it works as dictionaries, and you have to do.
Yeah, whatever. The entity resolver does exactly the same
yes,
thing.
You can do it now. You can do it now.
What about like more nested data structures? So now you have to.
Well, I don't do those. Unless with I recompose them basically. So if I have them like this, I actually instantiate every object itself, and then I know the structure, so I recompose it.
Okay.
I did some experiments with, maybe some people know that I actually wrote a driver for an Hibernate to table storage. It exists, don't use it. But that could actually do it. So it would reflect on the structure of your objects, and then it would create the mapping. Not with traditional relationships between objects, but it would use the, what's the name again? The embedded objects in Hibernate.
What makes
the name escapes me, because I knew that. So I wrote a driver that allows you to use an Hibernate to table storage. It works. It's used in N-Service Bus. I want to kick it out, but it's still used in N-Service. The main reason that I want to kick it out is because table storage is very basic on querying. People that use a Hibernate are very used to rich querying capabilities. You will never get those. Okay? Or if you get them, it will hurt. So that's why I do not recommend using anything like a real ORM on top of tables. It does not fit. Okay, so now if I then want to do a query, I can obviously not query that original thing unless I want to have a specific aggregate. But if I want to query, what I do is I store it upfront in the way that I want to query it later. That's why the audit log is so very important, because I have no clue what I want to query in like a year or so. So if I have another query type, I will have to regenerate my tables based on the audit log. Now, if I do create such a secondary index, what this basically is, then I will typically choose my partition key based on the way that I want to query it. In this case, these numbers are reverse time since the end of time, max value, and then so they are ordered in most recent way. In this case, so in this case, I have all of the orders in the partition key on a certain date ordered with the most recent on top. Basically, that's what it is. And then the row key can be used to order internally in that setting. This guarantees that for my specific query, I get a fast response time, because I know how I will be querying it and how many data I'll be getting back from the partition. And I have different copies of these depending on how you want to look at the data. And that's why the inbox and the action list and whatever calendar or whatever is still in there is a separate table, because you want to do it based on different conditions. Once it's the state of the object or the user, and the other time is the context or the time and things like that. So I need to create multiple copies of the data.
What happens?
What happens if you want to support a new kind of query in the future?
I grab my audit log, push it through some code of mine to recreate the state.
What happens if you already processed 10 millions of messages? Do you need to process them all again?
Currently, yes. Yes. I don't think there's a real way around that. Because you cannot provision the way that you will query it in like 5 years. You can't.
So users get notified you processed their order again?
No, no. I did not process the order, I just indexed it in a different way.
Yeah, but if you reprocess messages and your handlers notify your client.
Ah, like that, yeah, I need to turn it off.
Yeah.
Correct, I need to intercept it. Yeah. What's also important is do please denormalize. If a certain view has an aggregate view, pre-compute it and store it into tables. Do it. And these are some great partition keys. Any property on the object, of course. Also the user, obviously, because you want to give the guy his own data. For time, typically we use this. Decimal 19 numbers, starting from max value minus UTC now. This gives you reverse order, so in most recent first. For storing locations, there is a very nice algorithm called GeoHash algorithm that gives you a string for X and Y coordinates. Again, it's a very good partition key. Also because it allows you to do matching for proximity. But one thing that you need to make sure is that all partition keys are also on the original root. Because otherwise, if you ever have a change to those things, you cannot propagate it to the secondary indexes, if you had stored them that way. Or you would have to scan your entire table. Something you learn very late in the process. Okay, so for handling the lack of transactions, it basically works like this. So my web role sends a message to queue on my worker. That one then updates the primary instance, so with the partition key being the unique identifier. Then it says, I'm done, and some secondary handlers actually update the secondary indexes, and if you have multiple, I do it in parallel. Right, so it's done pretty fast. And I also send it back to the user in case that's needed. Right. This way you can also maintain caches in memory very easily. So if you have changed data in a cache somewhere, you can update it in the same way as that you updated it. Okay, this is something I think I can actually create generically. I think. I'm trying. And I want to offer this entire bounce of primary updating, secondary updating, doing everything for you in one go and make part of message handle. I'll be sure next week that it's finished, but currently it looks okay. And besides that, I hope I can invite you to come around for wave.com and whenever I run my next test, give me feedback on whether you like it or not.